Okay, in this video we want to go on to number 47 and hopefully 49 of this particular section. And I think it might be most helpful if we try to do this as visually as possible to get the idea of what's happening here. So I'm going to bring in the graphing calculator. And again, we're using the calculator not so that we don't have to do the math, but we're using the calculator to help us visualize what it is we're doing when we do the math. So it's very important, even though we could find these answers just using the calculator. We still need to be able to do the math, but the calculator helps us understand what's happening. Alright, so I'm going to put in this function, and that is y is equal to the square root of x. And we want this for x is equal to 4 to 9. I'm going to set my window to go from x equals -1 to 10 by 1s, and the y values can just go from -1 up to, I think 5 should be sufficient, by 1s. And let's see if we can get a whole picture of the graph there. And we can. Alright, so what I'm going to do first is take an image of that and then move it onto our screen. And that's just so that I can draw on top of it. Alright, so we want from 4 to 9. So 1, 2, 3, 4. And then 9 would be 5, 6, 7, 8, 9. So we know from what we've done so far that there is an area under this curve. And that would be equal to the integral from 4 to 9 of x to the 1/2 dx. And we can find that area. But what we're looking for is there's also a height somewhere along here. Let's just say it's roughly around there, where there is an actual a horizontal line drawn through a point on the graph, and that horizontal line defines the top of a rectangle that has the same base as the integral area that we're looking at. And if we get that line just right, the area of my rectangle and the area under the irregular shaped curve will be exactly the same. So we're going to call that, we can kind of see where it's going to happen here, C. Now if we just wanted to estimate 4, 5, 6, it looks like it's somewhere between 6 and 7 that's going to happen. And on the y-axis we're going to get 1, let's see, 1, 2, 3, somewhere in between 2 and 3. So the x value will be somewhere between 6 and 7. The y value will be somewhere between 2 and 3. Alright, so how do we start this off? We know that that is equal to f of c, which is the height, times b minus a, which is 9 minus 4. And that is 5 times f of c. So integral from 4 to 9 of x to the 1/2 dx is equal here, right? So the next thing we can do is just divide by 5 on both sides. So we would get 1/5 integral from 4 to 9 x to the 1/2 dx is equal to f of c. That tells us that's the height along the curve that defines that horizontal line, which is the upper bound of the rectangle there, right? Which is the height of the rectangle. And so all we need to do then is to everything on the left we can calculate algebraically. Then we're going to set the function equal to that value and solve for c. Alright, so remember that f of c in this case is f of x is square root of x. So that would be c to the 1/2 power. So that's what we're going to do. So first of all, we're going to find the antiderivative. Antiderivative of x to the 1/2 is x to the 3/2 divided by 3/2, so that's 2/3 x to the 3/2 from 4 to 9. And we're going to plug in. Again, remember how we evaluate a rational exponent at a particular value. We can take the square root first in this case. So square root of 9 is 3. 3 to the 3rd power is 27. So we have 1/5 and I think I may have been writing there while the video was actually stopped. So we evaluated the antiderivative at the upper limit minus the antiderivative at the lower limit, and we're going to multiply that whole thing by 1/5. Now I believe we get 1/5 times 18 minus 16/3. 18 is 54/3. And 54/3 minus 16/3 is 38/3 times 1/5. I think that's going to give us 38/15. And that would be equal to the square root of c. Alright, so that's roughly, again, that's somewhere, if you can see right away, that's somewhere between 2 and 3. So our x value, no, that's, yes, that's somewhere between 2 and 3. That's the y value. C to the 1/2, remember, is the value of the function when x is equal to c. And as we said, that should occur somewhere between y equals 2, y equals 3. Then to find c, we're going to square both sides. So c would then just be equal to 38/15 quantity squared. And we are going to need the calculator for that. So 38 divided by 15, I don't think that they have any common factors there. 38 divided by 15, let's just see, we can reduce it using math, and no. So then we're going to square that result, and we end up with 6.4177. And again, remember what we said, the c value, that's 1, 2, 3, 4, 5, somewhere in between 6 and 7. So that does make sense. Now we're going to verify all of this using the calculator again. But we found the c value, and we did find the f of c value, which is so in this case, this is the c value, and this is the f of c value. That's the height of the curve where the rectangular area is going to equal the area under the curve there. Alright, so 1 is a y value, that's the f of c, and 1 is an x value, that's the c value. Alright, so let's see if we can verify this using our calculator. So we have our function y equals the square root of x there. And what we're looking for is at 38, what is the x value where the y value is equal to 38/15? So we're going to put in the 38/15, graph that, and you're going to see that's some y value in between y equals 2 and y equals 3. We're going to use the calculator to find the point of intersection. Option 5, that's the first curve, we hit enter. That's the second curve, we hit enter. And guess, we just hit enter there, and we end up with 6.4177, etc. So that is the height of the curve where the rectangular area formed by a horizontal line at that height with the base of 4 to 9 will equal the area under the curve of square root of x from 4 to 9. Alright, we'll go on to the next problem. So in number 49, we're working with the function 2 times secant square of x. And this is instructive in using the calculator. We don't have a secant function. We have sine, cosine, or tangent, and we have their inverse functions, but we don't have their reciprocal functions. So what we're going to have to do, secant squared of x, remember, is 1 over cosine squared of x. So in this case, it's 2 times that, so it'll be 2 over the cosine of x, and I wrap that in parentheses, quantity squared. So to find our window for this, let's take a look at what we have here. We want to go from negative pi over 4 to pi over 4. So x values, I'm going to say, let's go from negative pi divided by 2 to positive pi divided by 2. And let's have that go in steps of pi divided by 4. And notice you can put in the pi's, it'll convert that all to decimal form there. And our y values, I'm not exactly sure what we're going to need here. Let's say from negative 5 to positive 5. And if we need more, we can adjust it. So let's take a look at what that graph looks like here. Alright, I think we're okay. So we can see everything from negative pi over 4 up to pi over 4. So our area, let's take a snapshot of that. Okay, so in the terms that we've been using, we know that there is an area under the curve from negative pi over 4 to positive pi over 4, and we'll call that our red area there. But we could take that same area and form a rectangle, and it probably would be somewhere a little bit lower than the highest point on there, but perhaps like that, and we could form a blue rectangular region that would have the same exact area as the area of the red region, right? So how do we do that? We're going to set up, let's try to do this as quick as possible. I'm going to move the 2 out, because that's a constant multiple, secant square of x dx, and that's from negative pi over 4 to positive pi over 4, and that has to equal f of c times pi over 4 minus negative pi over 4. And that's just pi over 2. So pi over 2, and our f of c here is 2 times the secant square of x. Well, we'll get to that in a second. So we have pi over 2 f of c. And on the right side, on the left side rather, let's go ahead and evaluate that. We have 2 times the antiderivative of secant is simply tangent. Secant square of x is tangent from negative pi over 4 to positive pi over 4. Tangent at pi over 4 is 1. Tangent at negative pi over 4 is negative 1. And so we're going to end up with a region of 4 there. And we'll verify that really quickly on the calculator. So we have option 7, negative pi divided by 4 to positive pi divided by 4, and we're saying that that area should equal exactly 4, which it does. Alright, we'll move the calculator out of the way for a second, and before I do, I'm going to clear off the shaded region. I'm going to run out of time real quick here. So first thing I want to do is multiply both sides by the reciprocal of pi over 2. And so I know the height that I'm looking for is 8 over pi. And f of c is 2 secant square of c. Divide by 2. Take the square root of both sides. Simplify that just a little. Reciprocate both sides. use the inverse cosine function